back to another Kin seminar series to everyone in person and everybody online on Zoom. Today, we're going to have two speakers. We're going to have Dr. Amir Golalipour, who is a highway research engineer in FHWA's Office of Infrastructure Research and Development. He's responsible for planning, conducting, managing, and reviewing research and development activities associated with infrastructure resilience. He holds a bachelor's from the University of Pavement in Iran, as well as a master's and a doctorate degrees from University of Wisconsin-Madison, all in civil engineering. Our other speaker joining Dr. Golalipour is Dr. David Mensching. He is the Asphalt Materials Research Program Manager for FHWA. He is also the director of the Fairbank Highway Research Center's Asphalt Binder and Mixture Laboratory. He is the chair of the Transportation Research Board's Standing Committee of Binders for Flexible Pavements, and he is an active member of the Association of Asphalt Pavement Technologies. Dr. Mensching holds a bachelor's and a master's from Villanova University and a doctorate from University of New Hampshire, all in civil engineering. We wanted to have them both because we recognize that pavement resiliency is becoming an increasing critical consideration, and they are here today to talk about it. Dr. Mensching, Dr. Golalipour, welcome. The screen is yours. You can start sharing whenever you want.
Okay, can you see my screen? So is now the screen sharing working?
Correct.
Awesome, and you guys can hear me too, correct?
Correct.
Perfect. So good afternoon, everyone. Thanks for the opportunity and inviting us to talk regarding the pavement resilience topic. As mentioned, this is a topic that now it's a lot of discussion about it, and we wanted to present some of our ongoing activities regarding the pavement resilience and also receive feedback from you regarding some of our future projects. As mentioned, Dr. Dave Mensching and myself, we are going to co-present. I'm going to start the presentation, and then Dave is going to jump into some more details about the asphalt materials research on resilience. So before we get too far, we need to have a definition that everyone can use it for resilience. So Federal Highway has a definition for resilience, and it's in Federal Highway Order 5520 is the ability to anticipate, prepare for, and adapt to changing condition and withstand, respond to, and recover rapidly from disruption. Federal Highway definition is more geared toward climate change and extreme events. And why this is so, the issue of extreme event is important to Federal Highway and our partners is because communities across the United States are experiencing extreme weather events that damage their roads, bridges, and cost a lot of money to repair, and also the impact of it on economy. As we've heard, the situation that happened in Texas during the winter time, that they had the whole system power grid basically shut off. Those are all related to the climate change, and also we need to make sure our infrastructure is prepared for that. You can see in the pictures here that from California on the left-hand side all the way to New York to the right-hand side of the picture, coast to coast, we seeing the impact of the climate change and extreme events. So that's why we need to be prepared for that. One thing that we want to always consider, what's the environmental impacts on pavements? It's a study that I'm putting here. It was done by Turner Fairbank Highway Research Center back in 2016. And this is coming from the LPPP specific studies that they were looking at only on environmental impacts on pavements, both for flexible pavement and rigid pavements. And as you can see, about 36% of total damage for flexible pavements are coming from climate factors, environmental factors, and for rigid pavement was 24%. So that shows that the impact of environmental factors on our pavement is very significant. However, right now in the pavement design that we basically, the process that we use, we just use stationarity data. So basically we use the past historical data and we forecast it. However, as we know, the climate is changing. So now we need to consider the future climate projections to be able to be prepared for the changes. Some of the consequence of assuming a stationarity for flexible pavements, we are going to higher average temperature. So that means that we may have more rutting. And that means that we need to change either our mix design or binders. And also it's going to increase the age hardening of asphalt binder. Asphalt binder is going to age faster when you have a higher temperature. Moisture changes is going to impact not only our pavement damage, also is going to impact the layers beneath the surface pavement, and it's going to impact the shrinking or swelling. Also, increased precipitation is going to change the basic soil stabilization, and also is going to impact the soil modulus. When we are doing the pavement design, we are assuming some modulus for the sublayers, and when we have more rain and flooding, that modulus is decreasing. So that means that the load capacity of our pavement structure is decreasing. So those are some of the consequences of if we don't consider the climate change and future climate projection. Application to the pavement, one of the basically steps to consider resilience for pavement is monitoring the trends, looking at how our pavements are behaving right now and looking into the few years to see if that trend is changing or not. Some of the key pavement indicators to monitor for those changes, as you can see for asphalt pavement indicators, we have rutting, we have low temperature cracking, we have raveling, fatigue, and other things. As I have on my slide, we have all of these information published as part of federal highway work. So if you look at the links, you can find these documents. The next step after looking at the trends is evaluating vulnerability. So basically when your trends are changing, for example, if previously you had like 1 or 2 big floods, but now you have like multiple 500 years flooding in your area, that's what we have been observing in North Carolina, then that's the time that you need to start acting. You need to evaluate the vulnerability. We have a tool, it's called Vulnerability Assessment and Adaptation Framework, that it was developed by Federal Highway. This is a tool that you can use for a scoring, basically to see where are the issues in your system, in your network, find those vulnerable points and basically try to address those specifically. And you can input local data sets into this. And after that, based on those vulnerability assessment that you have done, then you can use this tool that we call it adaptation decision-making assessment process to plan and design your infrastructure to meet the future conditions. It's a risk-based approach that could be used either by planners or designers or engineers. And the good things about it is that you can customize that to your own state. Some of the decision-making factors in this process is the life cycle cost, the resilience, the political settings. Again, I have the link here that you can go and basically use this tool for free. So now that we kind of talked about the general approach for the pavement resilience, it's good to talk about some of the case studies. We have done many case studies, and these are some of them that we call them TICA studies, transportation engineering approaches to climate resiliency. 5 of them are listed here. I'm going just to talk about 2 of them just because of the lack of time. One of them is a Texas study, and the other one is the Maine study. Both of them, the stresses that we looked at was temperature and precipitation, and we are looking to study the impact of it on pavement. So the first one is the Texas study. It was done in an area close to Dallas, Texas, and the proposed project was for the new construction. And we wanted to evaluate the temperature and precipitation impact on the pavement performance. And we used some projected climate data. So this is very important. We didn't use the historical data. We are using the climate models to look at the future climate projection. I'm not sure how much you guys are familiar with some of these models for future climate projection. One of the main models that have been used by environmental scientists and planners is called RCP, is Representative Concentration Pathway. Is basically is a greenhouse gas concentration model. So basically it's trying to look at that how much greenhouse gas we are going to have in future in the next, like, let's say 100 years. And based on that, it's going to look at the impact of that on the temperature, precipitation. There are different scenarios. RCP 8.5 is the most extreme scenario, that if we cannot control the greenhouse gas production, what's going to happen? And RCP 4.5 is more conservative, basically. So we can see the range of different type of this type of model. Typically, in a lot of studies, they use one extreme, the 8.5, and at least one, basically the conservative 4.5. Based on this, 20-year moving average of the mean temperature for Dallas area, by 2100, if we use the RCP 8.5, that's more extreme version of it, our temperature is going to change from about 65 to 76. As some of you know, for asphalt pavement, that means that we are jumping 1 or 2 grades. If we use the more conservative on 4.5, still we are going to have an increase about 6 degrees of temperature. So that's almost a grade of asphalt binder. So that's why it's very important for us to look at the climate projection, not the historical data. This one is looking at the moisture changes. This index that typically they use is called Thorndike Moisture Index. Basically, this parameter is a useful indicator of the supply of water in an area relative to the demand for water. So it's basically looking at how much demand you have, how much supply you have, and based on the calculation, it's going to show you if you have decrease in TMI, that means that you have an increase in the risk of aridity and drought. Also, when you see, and that means that you may have increased potential for vegetation growth, and also to impact your voids for your pavement. And you can see based on the different models how much change, decrease in TMI we will have by 2100 based on different models. So in this study, what we did, we used this information climatic data, and we use pavement ME to see that how much is going to impact our pavement performance. And as you can see, the green one, it shows your asphalt concrete layer rotting. The red one shows your subgrade rotting, and also the blue one shows the fatigue cracking. And in all cases, as you can see, no matter if it's a new construction or rehabilitation and in which time frame you are looking at it, you are going to have more distresses for your pavement. For example, if we are looking at all the way to 2069, your rotting can be increased by 33%. One way that you can take care of it, you can use a stiffer asphalt binder grade. Rather than using PG70, you can go to PG76, and that can take care of some of those issues. For rigid pavements, if you guys are interested to know how it's going to impact the rigid pavements, we are going to have drawing shrinkage issues, and we are going to have some curling distresses. And also the crack width is going to change. So basically that means that we need to have more reinforcement for our concrete. Some of the lessons learned about this, we know that by increasing temperature and aridity, we will see some impact on our material properties. Our soil is going to be drier, our asphalt is going to be more soft, and we are going to have more shrinkage in the concrete. However, one important lesson learned is that we have some strategies that we can use for resilience. Like for example, for asphalt binder, asphalt pavement case, we could use just a stiffer asphalt binder without a major cost increase, and we can take care of that. So that's a good news for us. There was another study, it was in Maine. This was also looking at the temperature and precipitation impact on pavement performance. And it was on a rural highway. And we wanted to see that how the projected climate data using, again, pavement ME, how it's going to impact our performance. I'm just putting the results of this study. As you can see, we had increased rotting and cracking. So to take care of that, either we need to increase the pavement thickness or use a polymer modified binder. Also, because the change in the freeze and thaw cycle, we are going to have change in the subgrade modulus. We need to have some restriction on weight for the trucks, and that's going to have some economic impact. So there are some of those that we need, some of those consideration that is important to understand. These are some of our resources that they are all free for you guys to use. The tools that I talked about, the vulnerability and adaptation framework that I talked about, the vulnerability assessment tool, all of those tools that I talked about, plus other case essays, the T case essays that I just talked about, they're all available on this website. As you can see, it's FHWA.dot.gov, Environment, Sustainability, Resilience. And you can find a lot of good information over there. With that, now I'm going to let Dr. Mensching talk to you guys about how the asphalt material research program is related to resilience effort. Okay, please take it away.
Thanks, Amir. Yeah, so with this increased emphasis in resilience across FHWA, and then we're seeing more and more in the news that there's a need for this research. The Asphalt Materials Research Program has identified resilience as one of our thrust areas. And I'd like to just go through a few slides before handing it back to Amir as to how we came about that process. So the slides I'm going to be showing here, the majority of them are from our 2019 strategic planning process that we did within the Asphalt Materials Research Program. We started with the issues, right? What are the major issues impacting infrastructure and therefore asphalt pavements in the US? We have an increasing traffic and climatic demands. This speaks directly to concerns of resilience. We have increasing competition in the global marketplace, a changing quality and quantity of resources. The amount of high quality virgin aggregate is declining, for example. We have an evolving world of automation and the Internet of Things. Coming onto the scene in the future will be connected autonomous vehicles. And so there's a need to kind of tie asphalt pavements to those vehicles and have them communicate well with each other. And then there's a decreasing experience and availability of an agency workforce. And this actually extends not only to agencies, but on the contractor side as well. And so these are kind of the issues that helped steer us when we came into developing our plan for research for the next 5 to 7 years. This slide here provides a strategic overview of our program. Our mission is simply to lead with world-class expertise, technology, innovative research to solve unique problems of national interest, and to sustain the economic vitality of the American infrastructure. So more specifically, if we drill down one level beyond our mission, we have 3 strategic objectives, and they're in the areas of people, technology, and innovation. If you look at the slide here, the objective as it relates to people is to address stakeholder needs and have strong research and deployment focused partnerships, and to have the highest level researchers within our program. And we're very fortunate to have the experts we do. In the area of technology, we're looking consistently to improve existing technology to address the needs of the American public. And then as it relates to innovation, developing practices and tools for practitioners, which are going to improve longevity, safety, and sustainability of asphalt pavements. Now, drilling down even further, just to provide you with this context of where we're going in our research. We have 7 focus or thrust areas, if you will. The 4 in green are active now. And those would include research in long life wearing courses and innovative materials, performance specifications that would speak directly to topics involving balanced mix design or performance related specifications, for example, wrap-raz and sustainable materials, and then refining the binder specification. Now the 3 in yellow below are emerging focus areas for us. And this is where we expect to go over the course of the next 5 to 7 years, really. So we're making movements in these areas now, position ourselves well for the future. And so those 3 areas would be automation and artificial intelligence, connected pavement materials. And what this means is really positioning our program to be a player as it relates to connected autonomous vehicle implementation in the US. And then the last topic, which we're just starting up. And so one of my slides is actually just some of our initial explorations in the area. And then if you've got any feedback at the conclusion of the presentation or even afterwards, I'm very welcome to hear that. The area of resilience and materials. Next slide, please. Okay, so for those who aren't familiar with our program at FHWA, I've provided a slide on our structure. The overwhelming majority of our research is done through the asphalt binder mixture laboratory, which is housed at Turner Fairbank, just outside of DC. And we have 2 branches, if you will, to the laboratory operations. One is our research. That's a long-standing element of the laboratory. Of course, it's been a research lab for many, many years. And then we have this branch, again, if you will, call it a branch, focused on implementation and delivery. And so what we do in this side of the lab is focus on high impact national interest issues that are solving a problem within a 6 to 12 month time frame. And so this is less of a basic or even applied research effort and more in terms of actually deploying a technology across a number of different states. We partner very closely with the Pavement Test Facility at Turner Fairbank, or the ALF, Accelerated Loading Facility, as I think many of you are aware of. And then here and there, we have out-of-house contracted research. And so that would be an instance where we're filling in some of the last dots in a particular research topic. And we may actually put out an RFP for universities or contracting firms to conduct research off-site. And then we have an ongoing presence for visiting scholars. So whether it's postdocs, interns, graduate students, university professors who are on sabbatical perhaps, we're always welcome to discussing those opportunities as the interests align. Next slide, please. And then the last slide I've got before handing it back to Amir and to finish off the presentation is really what we're doing in the asphalt materials area for resilience. And as I mentioned, we're just starting up here. And so any feedback is much appreciated. But 3 efforts we've identified, at least to get started, are shown on the screen here. The first would be quantifying impacts to structural response due to emergency and cleanup. So if you've got a natural disaster that comes through, and you know, the conversations that are being had around climate change and resilience would suggest that these are going to happen more frequently. There's instances where roadways that are not designed for very heavy traffic in a very heavy frequency are going to actually experience it. And the quantification of that impact on the pavement life is not well understood at this point. We're also constructing a test bay at the pavement test facility that will be able to flood pavements. And so we'll be able to get a better sense of how the pavement substructure and the mix, of course, on top is going to handle more frequent inundation, whether it be due to storm surge or flooding or just sea level rise in general. And then the last topic here, this is kind of a little bit more out of the box for us, but wildfire exploration. So we've seen so many examples, you know, seem to be focused in the Western US, where wildfires come in and really can devastate communities. And so we're taking a look at whether or not, you know, agencies should be considering designing upcoming asphalt mixtures for wildfire resistance. And so we've got opportunities at Turner Fairbanks to do this both in the laboratory, but also at our pavement test facility, either on the alpha lanes themselves or our test pits that we have for those who are familiar with the facility. So with that, I'm going to hand it back to Amir to wrap up, I think, a little bit more on his program.
Thanks, Dave. Before getting to some of the ongoing research that we're doing in my program, I wanted to highlight what Dave brought up in this slide with these 3 points. We held a peer exchange on pavement resilience last year. We had 2 sessions of that with stakeholders from DOT folks, from academia, from industry, and always topics that they came up. One of them was flooding because of the sea level rise, because of the inundation issue. We have a lot of flooding issue around the nation. It's not just the coastal states. A lot of places like Midwest right now, they have a lot of flooding issue with their pavement. So that was one of the #1 topics that came about. The other one was about the emergency response and recovery process, because when, for example, you have a flooding situation, your pavement structure is not as strong as it is in a normal condition. And at the same time, you have more loads on it. So state DOTs, they're asking, okay, when is a good time that I can open my pavements to the traffic or to the emergency response traffic? And if I have to open it, what's going to be the damage on my pavement? So that's another topic that everyone talks about. And wildfire, if we watch the news, we know how severe the situation with the wildfire in the West Coast area is. So in regard of that, we have done some projects, and we are doing some other projects. One of them was assessing flooded pavement project. This project was completed a couple of years ago, and now we are working to get the report published. Actually, I was just working on the report before coming to this webinar. And in this project, we are specifically looking at what are the procedures to assess the flooded pavements, and also assess the capacity of it for the traffic, the normal traffic or emergency or heavy equipment. and also trade-off between the user cost and the road closure. So, and as part of this project, we have developed a decision support tool. This project was done by University of New Hampshire for us, and hopefully we can have the report published in the next couple of months. A new project that we just started October 1st is a joint project that we are doing with the National Center for Coastal Ocean Science. It's an interagency collaboration between Federal Highway and NOAA that we are looking specifically on impact of the sea level rise on surface transportation resilience. And we are trying to see that, okay, what type of models or tools we can develop that we can look into impact of the sea level rise, not only on surface transportation, also on the holistic, looking at the biological process and looking at how we need to do some resilience activities to be prepared for the sea level rise. This project, actually, we had a congressional hearing about it just a couple of weeks ago. This project has two focus areas. One of them is coastal resilience focus area, and the other one is surface transportation focus. And as you can see, we have three main objectives. One of them is quantify the vulnerability of the surface transportation system. And when we are talking about the surface transportation system, we are talking about pavement, railroads, and any type of surface transportation system. And then we want to quantify the social, economical, and ecological benefits of some of these solutions, and then definitely predict the impact of the sea level rise and inundation on the performance of this surface transportation infrastructure that we have. Another project that this has not started, hopefully I will be able to start this project in the next few months, is specifically looking at wildfire impacts on pavements. As Dave mentioned, this is an extreme event that's happening more and more often on the West Coast, in California, Oregon, Washington, Colorado. And right now, the information on this topic is not that much. So this project is trying to determine the state of knowledge and also to find the research gaps and needs, because we don't want to solve an issue that does not exist. So this project is going to lay down the foundation for the wildfires impact on pavement, and based on that, we can continue with more projects. Also, we are trying to put together a roadmap. As I mentioned, we had a peer exchange for pavement resilience, and also we had a highway resilience to wildfire events. We had another peer exchange. So based on those information, we are trying to identify the gaps and the future needs and trying to put together a roadmap. One of the things that based on our peer exchanges, we noticed that one of the important tasks for us is to educating our pavement engineers on resilience. And for that, we need to document the state of knowledge for them and try to put together trainings. And for that, we are putting together an NHI, National Highway Institute course specifically on the resilience. And it has a couple of modules specifically on pavements. Also, we are working on a pavement resilience technical guideline. We are almost done with the report, and we are trying to send it through the publication. So hopefully in the next couple of months, that report also will be available. How you can help. You can encourage your agency to consider the resilience in planning, design, and operations. And also, you can use or help disseminate some of these resources that I mentioned, that they are all free. And the most important part, we need to continue research. As Dave mentioned, his program is focusing on resilience for asphalt materials, and my program, we are focusing on infrastructure resilience and also pavement. So we need to continue research because the state of knowledge on this topic is limited, and it's time for us to expand information and knowledge and expertise on this topic. With that, I wrap up our presentation. Here is the contact information for Dave and myself. if we would welcome to hear feedback from you guys about some of the research ideas or projects that we just talked about. And also we would welcome you guys, if you have any question later on, you can email myself or Dave. With that, thank you, and we welcome any questions that you guys may have.
Do you have any questions from the room here to start with? Check it out. Chat here. Okay, I guess I can start with one question. At the beginning in the introductory slides, you mentioned that one of the challenges that we're going to face is decreasing experience in agencies. And I was wondering, why is that, and how can we fight against it or prevent it?
I think that was on my slide.
Yes.
There, Amir. I can take a first stab at. Yeah, it's an issue that I think we hear about a lot, and FHWA is actually working with National Asphalt Pavement Association, NAPA, as well as some of the other infrastructure advocacy groups to try to get at that issue, actually. So what we, in our program, we're looking at when we identified that as a critical issue impacting both infrastructure and asphalt materials was, how do we broadcast that asphalt materials is on the cutting edge, both, I mean, there's research that's being done, of course, cutting edge in the asphalt materials realm, but how are we kind of positioning ourselves as a field where engineers coming out of university, for example, are going to be attracted to the community. And for us, that was taking a larger focus on artificial intelligence, automation, these types of technologies. And so what we're actually doing right now is we're putting together the first international data science for pavements symposium. And we're doing that with University of Missouri and University of New Hampshire. And the event will be held the end of March in 2022. And what we're going to try and talk about there is just how do we chart pathways for advancing research in this critical area, keeping the people that are doing this type of work in asphalt materials, keeping them in the asphalt materials community as opposed to joining, Google or Apple or some other, community that's really into data science. And then, of course, bridging gaps as it relates to implementation. So FHWA seems to have a multi-pronged approach to attacking this workforce development issue. I think you'll hear more as time passes on it, both within our program and just across our agency as we continue to work with people like, groups like NAPA.
Thank you. But I did have a follow-up. Is that decreasing or depletion of experience happening in certain states specifically, or is it general?
From what I hear, it's more of a general issue across the country. You've got engineers in agency positions and even in contractor, mixed producers and so on, who have such a wealth of knowledge, and now, they're retiring or seeking employment in other fields in some cases. But I haven't really encountered interactions where it's like a localized problem rather than just this is across the country. Everyone you talk to kind of has the same concern.
Thank you. Do we have any other question here in the room? You're having a game in right now?
In your analysis, have you found a temperature or precipitation to be more impactful for the life of the pavement? Regards to climate change. Can they hear me or no?
Could one of you guys repeat the question? Sorry, I couldn't hear all part of the question. I heard about the temperature and precipitation, but I wasn't sure what was the exact question.
In your experience, is it the temperature or the precipitation that has a larger impact on pavements with regards to the climate change?
That's a tough question because pavement, specifically like asphalt, is a viscoelastic material, so different parameters is impacting it, and in each area you have both parameters changing. It's not that, like, for example, in one area you have temperature changing and precipitation is the same, because as temperature changes, as I mentioned, the TMI, the Thorndike index is changing. So when that index is changing because of the temperature, then your precipitation and your aridity and drought is changing. So it's very hard to decouple those two parameters. Both of them are impacting your pavement. Some of the modeling work that has been done, again, you need to look at which area. For example, if you are in area like in the north part of the country, like Maine, the temperature may have a little bit more significant impact because of change in the freeze and thaw cycle that is impacting your subgrade modulus and impacting your pavement. In some places in like Florida, you may have more precipitation and more flooding, so then that it can have more impact. But at the end of the day, it's very hard to decouple those. You need to look at both those parameters, and as you know, in pavement ME, you have both of those as your input parameters.
I just had a follow-up on that question. Is there any initiative to decoupling them, or are they just, as you said, being addressed depending on the location that is being researched?
As far as I know, I have not heard any effort that they're trying to decouple them, because when you're trying to look at your pavement, you need to consider all the climate factors. Because when the climate is changing, both the temperature and precipitation is changing. So decoupling that, you may be able to do some laboratory experiment, but when you're trying to extend that to the field, it would not be, direct correlation, because in the field, all the climate factors are changing simultaneously.
Got it. I think we have another question in the audience. Puneet was raising his hand. You can go ahead.
I just had the follow-up. Since we cannot decouple these events, like what precipitation, temperature, or any other unpredictable event that can affect your payments, then would that make the decision making in making your payment more resilient be very expensive, or cost-wise? Like, how, if we don't know what factor may affect, then we'll go with a very high uncertainty, and that will add to making your payments resilient. So what do you think in terms of cost and practical considerations? How is it possible, accounting for all these unpredictable events together in a payment?
Okay, Dave, also please feel free to chime in whenever you would like. So regarding that, you are correct that when we are trying to make our pavement or infrastructure more resilient, we need to pay more. That's just, but that initial cost is more. When you are trying to look at the life cycle of your pavement, when you are doing analysis like LCA or LCCA, you will see that at the end of the day, that pavement, when it lasts longer, when it's a durable pavement, and its life cycle is longer, at the end of the day, your cost is not more, actually is less. For example, when there was a situation in New Jersey, it was Superstorm Sandy when happened few years back, when they tried to, one of their roads completely basically destroyed and they had to reconstruct the road. It cost them about more than $1 billion to reconstruct that whole network of the road. So when you're looking at that cost, and then you do the analysis, when you are you may a little bit pay more as an initial cost for your pavement or for bridges to make it more resilient. But at the end of the day, when you are doing the LCA analysis or LCCA analysis, actually your payment is going to be basically more affordable for you long term.
Thank you.
Sure.
We have a question on the chat. Lama, do you mind reading that for everybody?
Can you please address the following question? Can the designing criteria regarding the future environmental conditions be extended to every location, or is it required to perform case studies?
So could you please repeat it? I just want to make sure that I understand the whole question before I try to address that.
So can the designing criteria regarding the future environmental conditions be extended to every location, or is it required to perform case studies?
Oh, that's a very good question. So one thing that we need to do is that when we are looking at these climate projections, we need to look at each area or each region for that. We cannot extend the projection from California to Florida. Definitely, we need to look at how the climate change changes in for every region. And also, one part of this climate, the modeling for the climate is like the pavement ME process that every region, they were doing the regional calibration. We need to do the same for these future climate models to do some regional calibration. Definitely case studies are showing us how each infrastructure in one area is going to be impacted by climate change. But at the end of the day, we need to do some of those regional calibration to make sure that we are not over designing or under designing.
I have time for a question.
Yeah, we have time for one more. You can go ahead.
Thank you. Can I ask, so I looked at the projects you presented, and it seems that they're all about quantifying the impact of climate change on the pavements or the infrastructure. But do you have an idea on what measures to take in order to make the infrastructure more resilient? Like, can you give an example?
Yes, very good question. So like I'm going to give some example regarding the flooding, because everyone now is talking about flooding because of the coastal states and also like Midwest flooding that we have. Can have different strategies. One of them is that in some areas, in coastal areas, you have to elevate your pavement. It's going to cost you a lot of money, but you have to do it. So basically, you are going to have more for your sub layers. So basically, instead of your pavement being here, it's going to be moved off. That way to have less impact for flooding. Another strategy is to use porous pavements, to use some pavements that can take care of the surface water. So we all OGFC, open graded friction courses, have been successfully used in the nation. So now we may be able to have OGFC layers that is a little bit thicker, or we can have the total porous pavement structure. That's one of the areas that I think also Dave and his team, they have thought about and discussed about it, that a porous pavement structure, that your whole pavement is porous. Some other ideas is to using some different materials that they are more durable in terms of moisture damage. So there are different strategies that you can use. It depends on how much, first of all, budget do you have, and also how severe your situation is at. And also one other strategies that sometimes is being used, but again, it's not that much related to us as pavement engineers, is about abandoning the roads. For example, it was in Delaware that they had this road that it was getting flooded almost every week, and you cannot repair that pavement every year. But they saw that they had an alternative route, that it was just adding few minutes to people's commute. So basically they decided just to abandon that pavement because you cannot take care of the sea level rise is just happening. So sometimes that's also another strategy that sometimes needs to be done, but that's part of the discussion from the planners and the community people, not specifically pavement engineers.
If I may add to Amir's response, this is kind of one of the issues that we had in the asphalt materials area, is identifying avenues for research and resilience, because resilience, so much of the discussion is pavement level, network level, you know, and the question we've always had is where can materials fit in a bit more seamlessly? And so we're looking for bridges to our other focus areas to help us in the resilience topic. So Amir touched on OGFC. We're looking at coupling the OGFC mixture type with materials that we think are going to be highly durable. One example is diluted epoxy modified asphalt. You know, that also we're looking into whether it's got age retarding potential. We're doing that at the Alpha as well, where we're actually going to be asking the community for help in identifying additives with age retarding potential to place at the Alpha, and again, do the flooding and so on. But Amir mentioned with climate change, you've got the potential for increased rate of aging as the temperatures are climbing. And so that's kind of led us down this path of, you know, what materials are showing potential to slow that rate of aging to combat what we might see with climate change down the road. So I really like the question, because we've asked ourselves in our program the exact same question. We've done a lot of brainstorming about it and trying to find those bridges to work that we already have planned, or, you know, other ways that we can bring resilience into material specific.
One other thing that I would just wanted to distinguish for you guys is that the climate change has two folds to it. One of them is a gradual change. So your temperature is increasing, your moisture index is decreasing, but that's a gradual change that you need to take into account when you're designing your infrastructure, because now we design like bridges for 50 years, pavements more than 20 years. So definitely we need to look at that gradual. The other fold to the climate change is the extreme events, how we can have a pavement that can endure a hurricane. Right now we have 5 categories for hurricane, but because it's getting more and more severe, actually our discussion to add another level to hurricane, level 6. So how we can design our pavement or infrastructure that can, you know, withstand hurricane or withstand more frequent flooding. For example, as I mentioned, in North Carolina, they have seen 2 500-year flooding in the past 7 years. Imagine that pavement has not been designed for that type of flooding. So we need to design our pavement in a way that can tolerate any of those extreme events as well as the gradual changes.